Hi, John. Good to see you again, and thanks for doing this. I know you're a very, very busy man, so really appreciating you taking the time. Really interested to talk to you. 'Cause you know pretty much everything about this area, so happy to pick your brain on this one. I'm going to try and do my best to let you do all the talking, but as you know from being in meetings with me, I find that hard sometimes. So I'll do my very best. So to start with, if you could just give us an introduction on yourself and your career and things like that, that'd be really useful.
Yeah, absolutely. Well, thanks for having me, Carl. Really appreciate the chance to talk about data science, machine learning, AI, all that kind of stuff. It's a fascinating topic. So I think that, and there's a lot of interest around it, and maybe a lot of misconceptions as well. So I was relish a chance to kind of like clear some of that up a little bit, maybe, or give my perspective on it, which might not be right, because it's a big subject. But yeah, sure. So I've been my kind of like focus in my career for the most part hasn't really been on one particular subject matter. It's been more on a theme, which most of the time has been horrible, noisy data sets that don't appear to be of much value. How can you actually make something worthwhile out of it? How can you get value out of very, like, as I say, noisy, very messy, very incomplete data sets? That's been kind of what I've been interested in since I started work, basically. So I started as an astronomer, which a lot of people sort of, there's two reactions. One is like, oh, that's interesting, or can you tell me what your star sign is? It's the latter. I'm like, oh, sorry, I've got to go. Someone's at the door. Yeah, but that's where it started, in all honesty, because the particular part of research I was focused on was finding very, very subtle signals using telescopes, which are based on the ground. Now, you get a telescope on the ground, it's got the atmosphere to contend with. So that introduces a lot of noise, a lot of errors, and that can often overwhelm the signal you're trying to capture. Now, most of the time that's alleviated by using telescopes which are in space, but they're very expensive, they're very in demand, and there's a lot more opportunities to kind of like tinker with things on the ground than in space. And that was what I was really interested in, and that kind of my career kind of developed alongside data science as a term. So data science as a discipline has been around for maybe 15, 20 years, that kind of stuff. And I heard the first time I ever heard the term machine learning was in the first year of my PhD. So that was about 2009. So I kind of like, data science became in my sphere of consciousness just as basically I started working. And for a long time, I denied I was a data scientist until about my third or fourth role into my career. But I kind of like was always interested in the kind of hardware aspects, so migrating to the cloud, because when I first started work, all my computing was done on my laptop, which was quite heavy burden on it. Back then, I had to like do GPU processing. There was no such thing as a cloud. It was just that's it, all run locally. And yeah, I kind of like saw how technology and academic research into the field of what is now data science actually could get a lot of value. And initially, as I say, that was kind of in the academic space, or doing research, but then I branched out into business, into first of all, like working with alternative finance companies, which are things like crowdfunding, blockchain, all that kind of stuff. And that kind of bridged the academic and business part of my career. And then I moved more into the business focus thing. So I've worked at a fair few places, all of which are revolving around data science, particularly developing data science teams and how you upskill people, because there's a big kind of challenge with data science, which is you can do all the academic stuff, but then where do you get the business knowledge from, and vice versa? If you've been in the business for 20 years, where do you get time to train training statistics or training computer programming, all that kind of stuff? So I was kind of keen to bridge that gap as well. So that's kind of what I focused on in my career. And the last sort of 5-6 years, mostly focused on developing and leading teams in kind of senior leadership roles. So that's like head of type roles in data science and analytics.
Yeah, thanks for that, John. I love your background as well. It's always yeah, particularly when you can tell my star sign. I love that.
Uh,
No, I'm just
you're
kidding.
a
But
Scorpius.
but yeah, yeah, I think that's what's something that's really interesting, because I think over the last few years, data science and machine learning have become sort of very sexy topics, haven't they? And I think a lot of people think they've only been around since we've had these, kind of cloud environments, things like that. But as you sort of say, like people in the academic world have been doing this type of thing for absolutely years, haven't they? I mean, I remember when like my background was originally like in SQL Server development and things like that. I remember one of the SQL conferences I was at, it was very SQL heavy, like 99% SQL pretty much all the time. And then just one year, all of a sudden, we had like a lot of people talking about R and like the statistics side of things. So it was just, that's when it was starting to break in there. And that was kind of almost pre-cloud as well. But the people who were talking about R were sort of coming from that academic background. They've been doing that stuff for absolutely years. I mean, even back to like Alan Turing and people like that, they were pretty much doing like data science, but it wasn't necessarily called that back then. So it's yeah, it's really interesting, and I love that you've come from that sort of academic background as well.
Yeah.
So yeah, brilliant. Thank you for that. So yeah, so if you could tell us, this might seem like a very basic question, but I think it's actually really interesting to define it, is what is data science? And maybe even take us through the journey, how you kind of go from like a business problem all the way through to a data science or machine learning model.
Yeah, absolutely. That's a great question, and I'll caveat my answer is going to be different from other people's, because it's such a big subject that, of course, there's room for debate, for disagreement, and all that kind of stuff. But I think that, yeah, I think that there's from my perspective at least, data science is a combination of 3 different areas: computer programming, statistics, and business knowledge or business applications. Any 2 of those combinations are valuable. So they're kind of like computer programming and stats, that's more traditional academic research. They're kind of like computer programming and business knowledge is more kind of like analysis and the kind of report producing, that kind of stuff. But really the confluence of all 3 is where data science really thrives, and that's a good kind of way of looking at it. It is almost the combination of 3 separate subject matters to result in something that adds value to the business, and that's what we want to do, right? At least in a context of an organization, you want to do something that adds value, and I think that's where a lot of people can kind of lose faith in data science almost, because they think that, well, we've put loads of money in and we're not getting the results out. That often is a result of the focus is more on the thought process, like this is a good problem to solve because it's interesting, not necessarily what they should be trying to do, which is this is a good problem to solve because it's valuable. And I think that's the key difference in data science, and why a lot of the business problems, as you mentioned, they don't really have a chance to get solved, because immediately you're given a business problem and you go, right, what's the most interesting thing I can do to solve it, not what is the most valuable thing I can do. And often that's quite a simple solution. So in terms of an actual way in which a data science problem is solved from conception through to delivery, again, this can vary wildly by organization, subject matter, all that kind of stuff. But I think a nice way of looking at it is you get a challenge that the business has that needs to be solved. Now that can come from stakeholders directly. They can say, well, I want to get customer sentiment up by 15% by the end of this financial year, something like that. You can get actual data professionals looking at the data themselves going, oh, hang on, we've seen something interesting there. There's a potentially correlation between 2 different aspects of customer behavior, something like that. Internally, people have people have got like Excel spreadsheets or a bunch of different like SQL servers that are hosting data that's maybe not as optimized as it could be. So it starts with a problem that needs to be solved. The first thing that I would say to anyone is like, right, is that a problem, or is it a solution that someone's coming to you with? If someone comes to you with a solution, I would say don't do it, because in the head, if they come to you with a solution, if someone comes to you saying, I want a Power BI dashboard that gives me these 5 KPIs, I'll be like, cool, that's not a data science problem. We could talk about stuff, that's fine, but I'll direct it to someone else who's going to be able to fulfill that much better and much more efficiently than a data scientist would. The kind of problems that a data scientist wants to solve in general is much more around having the space and the capability to really pick apart a problem and then determine what makes it fundamentally relevant to solving in terms of a data-driven solution. So that isn't necessarily producing me a bunch of KPIs. It's much more around, well, what is the actual mode of operation when it comes to how can we change business and internal staff behavior? How can we change customer behavior to get a better result for the business and add more value? So once that kind of problem statement's been fully picked apart, and that can be the longest part of the process more often than not, then it goes into a sort of discovery stage in which you can do a bunch of experiments essentially. Now, this can be quite short because if you've got an idea about, well, it's just a more accurate forecasting, it's the best solution, you know, you're not going to spend ages pulling apart different kinds of models. You're just going to do some forecasting, see if it meets the need, and then that can be a kind of a solution that's developed from that point on. Other stuff's much more complicated to solve. So if you're getting into the realm of proper machine learning or even deep learning, like neural networks and stuff, that is going to be a much more complex problem and will take a lot more time to try and solve. So that kind of discovery phase is the most analogous to an academic research process that there is within a business context. So a lot of kind of background research can be done in that phase. A lot of talking to people, so drawing on other people's experience and expertise is also a really good way of approaching it. And then when you've got an idea about the solution that you're going to adopt, then it's about how we best deliver it to the end user. Now, the end user, again, might be an external customer, it might be an internal stakeholder. Ultimately, that then it becomes a kind of a classic, almost project management kind of challenge at that point, as in you liaise with the representative of the end user. You discuss what the best way of facilitating the need is, and you can then present it. Sometimes we want an Excel spreadsheet, which is painful but fine. Other times it's dashboard. Other times it's a brand new app, and that that might require some UX experience, or it might require a bit more kind of like user research focus and that kind of thing. It's a wide gamut, though. I think that's the important thing to know. There's not necessarily a single way of doing it, but more often than not, that's kind of how it falls into being.
Yeah, that was brilliant. I've normally got follow-up questions, but I think you pretty much went absolutely everything there. That's brilliant. Yeah, I think a lot of the stuff you say there is really interesting. That the combination between like the three, like what was it, the programming, the statistics, and the business problem. I think that's was that right? Is that that's the three you said, wasn't it? Yeah, I think that it's a really interesting way, because I think it's very easy to just pick two of the three maybe and go like, right, we're not going to think about the business problem as such. We're just going to use programming and statistics. And I think that is like, that can be dangerous, and vice versa. If you just focus on the business problem, you've already got an answer in your head. You're not actually using the statistics. Again, you've got another issue there. So yeah, that's brilliant. So the next question is there a difference between data science and machine learning? And if so, what is it?
So this is a great question, because again, terms are thrown about all the time, right? I mean, you and I have got sort of more insight into it because we work with data professionals with things all the time. But generally, when it comes to it, when people say anything in the realm of data, people who aren't as familiar with the subject matter immediately go to things like machine learning, which is quite in comparison, quite a small area of data science in terms of how you should solve a problem. Maybe not how it actually is solved, because people use machine learning algorithms to do everything nowadays, even if it's not warranted. But essentially, data science is almost like the entire subject matter revolving around those kind of three areas as I talked about. Machine learning is a subset of that. So data science is the overall subject. Machine learning is a part of that subject. AI is as well. AI is a broader term which encompasses machine learning, deep learning, neural networks, all that kind of stuff. Machine learning is a smaller part. So an example of an AI initiative would be something like any process that can replicate human behavior, right? So things like optimizing or optimizing an Excel spreadsheet, let's say. That a degree of that can be done artificially, without having to have someone click on every single cell and format the data properly. Machine learning is the next level of that in terms of complexity, in that it looks at data and then learns from that data. So as opposed to just replicating behavior, it replicates behavior and also learns based on the data that is given. So it can be much more complex. Machine learning in general tends to find patterns that a human being just can't see because of the volume of data that there is. Machine learning is used a lot, for example, in like seasonality trends forecasting and that kind of thing. And then it gets into, kind of like historically how things happened. So a good example that I'll always point people to is the Kaggle Titanic machine learning challenge. So that's a really interesting data set where you kind of try and predict if people survive or not based on a sample data set. And that's a really interesting example because there's a multitude of different factors that you need to consider, the age, the gender, what class they're in terms of, first class to third class, that kind of thing. So there's a lot of different parameters that you can look at and see, would this person have survived, yes or no, just based on the data that you've got. So I think things like that are a really good example. If people want to get into machine learning, I'd suggest starting with things like that, like with data sets that you can look at and go, oh, okay, I get this. And with that example, there's a bunch of algorithms, there's a bunch of, this has been done a lot. So there's a lot of examples to say, right, this is how I solved the problem. But it's never, there's always different ways of thinking about it. And that's, I think, the kind of the beauty of machine learning and data science is that it's a science, yes, but there's so many tools available to you that it can be thought about a bit creatively as well, which I always think is really, really good.
Yeah, there's not necessarily one set way to do everything as there is. There's, like you say, there's multiple different ways, and it's and you are experimenting a lot of the time, aren't you, in terms of like, we tried this and this actually didn't work like we expected, so we'll go and use this technique instead.
Yeah, and that can be a negative sometimes because, as I say, like the default for a lot of people is like, well, we'll build this machine learning algorithm and do whatever, and often that's just like too complex a solution. Like you wouldn't. I always say to people, well, you wouldn't use a sledgehammer to fix a dripping tap.
Yeah,
it'd solve the problem of the dripping tap, but you'd probably have some other problems coming up if you did do that. But at the same time, there's other things that would be more appropriate to use. So I think that's, I would always use the KISS, keep it simple, stupid, just to be like, right, let's reduce as much complexity as possible. We've got a bunch of tools we can use, but ultimately we do need to explain this to people as well, and they're not going to get everything. But you do need to relay to people who've got less experience. You do need to explain to them that this is roughly how we've done it, and this is kind of explain it like a 5-year-old kind of thing in some cases. That's not always possible, but I think you need to at least start breaking down the kind of like barrier to entry kind of thing.
Yeah, 100%. I think Einstein said something similar, didn't it? Something along the lines that a problem should always be solved the simplest way as possible, but not simpler. So essentially, keep things simple. Sometimes things will become complex, but don't make something complex just for complexity's sake, because, as you say, there's many reasons why that's an issue. Explain it to people, and even just then, your infrastructure, your architecture, and your services you put in place, it's much harder to manage something that's more complex. And as you say, using a sledgehammer to fix a tap is not a good idea. I've never done that before, John, but I can imagine that's a terrible idea.
I'll leave my DIY skills out of it, but I can speak from experience.
Mine aren't any better, so we'll leave that there. We'll stick to data. Yeah, so what do you think are the biggest misconceptions about data science?
That's a really good question. I think that there's a lot. I think that there's a lot of built, particularly around hype. I mean, I'm sure we'll get onto it, but talking about like LLMs and chat GPT in a bit. But that's seen as like, oh, this can do everything. This can solve every problem. No, I can't. I think that at the minute anyway. I think that's currently probably the biggest misconception is that, oh, we've got really good people. We've got ability to do all this really quite interesting, complex stuff and get some real value. Let's just do it. That will hand over a data set to that team and they'll be able to do anything with it. Problem is, it relies on having quite good data or the quality being of a certain level, which it often isn't. I think that is to me that as I say, like the current problem is the hype, but I think historically and still to this day, the biggest challenge is that, well, we've got data so we can do whatever. Problem is that, yeah, you've got data but it's not good. So how do you address that problem? That I think is basically one of the biggest misconceptions. Just because you've got data doesn't mean you can do anything with it.
Yeah, and I love that answer because you've very much preempted one of my other questions. And I was going to say this is a bit of a loaded question, but you've already teed it up for me. And what I was going to ask is, can you explain how important data governance and data quality are when it comes to building data science projects?
Absolutely essential. So the biggest challenge when it comes to trying to get anything that's valuable is the amount of data that you've got and the quality of the data that's there. So if you've got historically a lot of data that you want to do some forecasting on, that's great, but is the data of sufficient quality? Is there any missing data? Is there any are there any gaps that have already been imputed, that kind of thing? Has there been data that's been simulated? The documentation around it often is a big challenge. So you've got a data field. What's it actually mean? What's that telling you? If someone, as often happens, if someone's built an SQL server and then left the organization, it's like, well, I've no idea what any of this means. So I don't know how I'm going to get anything value out of it. And often that's where a lot of projects kind of unfortunately go to the graveyard, the data science graveyard. Just because it's not either the data quality or the actual governance around the data isn't of a standard where it can be done. And when it is attempted to be done, often it just results in something that's not really even usable. Another thing to mention as well is now we're getting into obviously machine learning, AI, very complex things with a lot of data. We have to consider the ethics of it as well. Like, are we using data for good?
Great point.
Often it's, when it comes to data stuff, business stuff in general, companies haven't really cared if they're doing the right thing or not.
It's fairly recent, isn't it? But it's
the actual use and drive for social good is much more a recent thing, which I think is absolutely brilliant and should be encouraged by every 100%. Person and organization. Problem is that there's still then a challenge to be addressed, which is around we kind of like building algorithms that ultimately will have impact on people's lives. Have the proper ethical ramifications of that been understood? We've got the kind of data side of it, which is, are we using the data properly? Is it sourced correctly? Have we got people's permissions where it's personal information? But then right through to the end, which is, we've done all that, we've sorted that all out, great. On paper, we can use the data, fine. But because of the way it's been collected or how it's been analysed in the past, or just the nature of humans so far to date, that data is going to be biased. So how do you account for that? It might have a significantly worse impact on people, who are disabled or certain ethnic minorities. Like, this is a real problem we're having to grapple with now. And things like self-driving cars, who's responsible if it goes wrong? Is it the person in the car? Is it the person who programmed it? Is it the company? There's a book by Yuval Noah Harari, which is called 21 Problems for the 21st Century. And
great book.
It sums it up amazingly, where he's talking about this problem. He goes into a massive amount of detail. Highly encourage people to read it. But he ultimately says that, well, this kind of like problem becomes the trolley problem. So do you prioritize the people in the car or the people outside the car? Do you have a Tesla altruist or a Tesla egoist? Like, and is that something that people should decide for themselves when they buy the car? It gets into some really interesting and philosophical areas that have just been thought experiments so far. So that's something that also has to be dealt with in this world of increasingly complex algorithms and the impact it might have on people. And that's an extreme example, but I think the challenge of governance and the quality of data is increasing exponentially as the complexity of the actual algorithms increases.
Yeah, and even though it is an extreme example, we're not that far away from having to make those kind of decisions. I'm going to say not that far. You know, let's say 20 years in the future, there's probably going to be a good chunk of self-driving cars around there. So those things need to be answered before you can, you know, do it en masse. So yeah, no, I think it's brilliant. And what you said about data quality and governance, I completely agree with. I think it's very easy to kind of say, even, you know, just a simple dashboarding project. You need that data quality needs. It's very easy to say, let's build a dashboard and we'll kind of do some fixes in the data to make it look sensible. But for me, I think if you could focus your energy on fixing that data quality in the source system, things like that, you'll get so much more downstream from that, rather than, as you say, a lot of these data science projects will probably go to the graveyard, because if the data quality is not there, you're just not going to be able to make, and it goes back to what you're saying, you can't make predictions on something that's going to impact people based on data that's not up to scratch, because it's just not going to work. And the bias stuff you mentioned as well is brilliant. I hadn't even thought about asking you about the biases, but glad you brought that up, because I listened to a talk, it's probably a few months ago now, and it was about like the way things are like designed in the world. Like, for instance, like car seat belts were basically designed for men, essentially, men of a certain height and certain size. So it's just all things like that. It's like that's all based on like a biased sample of data to say, like, we're going to make these decisions based on that, and it's all the same thing. So yeah, no, I'm very glad you brought that up. It's a brilliant answer, so thank you for that. Another thing that I'd be really keen to get you to talk about is data distributions. So in my, like, I understand it in a, you know, simple terms, in terms of like the way I would explain it to people if I'm talking to someone who's sort of not really in this area, is that you can have like normal data distributions, and that's something like, you know, a person's height is generally normally distributed, because even though you've got people who are very tall, like basketball players and things like that, they're still within a sort of normal range. Whereas something like a person's wealth, for instance, that's not normally distributed, because you've got people like Elon Musk and then people like, you know, who don't have any money at all. So it's almost the equivalent of having like a 40-foot person in that regard. So it's like, could you talk us through like the data distribution and then how that impacts data science projects and what you need to think about when you with that?
Yeah, absolutely. So great question. It goes back to the statistics thing earlier, right? I think that's often overlooked, the importance of statistics when it comes to really any data initiative that you're doing. It could be analysis, could be engineering, could be data science. The actual way in which you describe the data, often it kind of comes out at almost the end, right? When you visualize something through a graph or through an infographic or something like that. It's unfortunate that now a lot of people kind of go, let's just start messing around with the data without thinking about things like the distribution, because ultimately that determines exactly what you do and how you do it with the data. So you mentioned kind of like the normal distribution and then like a Poisson distribution, that kind of thing. There's a lot though. There's kind of Bernoulli distributions, which are binary. There's uniform distributions, which would be like a dice, you know, a fair dice. So each you got a 1/6 chance of each number coming up. You've got kind of T-tail distribution. So there's a lot of different things, and I wouldn't expect anyone to kind of just be well versed in all of them and know exactly what the impact of each distribution is going to be on the actual kind of the outcome of the project that you're doing. but it does determine exactly what you do. So just to kind of sum it up very briefly, any distribution, and normally it's called a probability distribution, essentially is how likely is it, based on a data set or based on a series of experiments that you do, how likely is it that an outcome is going to happen. So like you say, a normal distribution is kind of symmetric around the mean. So what I mean by that is there's a mean, there's an average, and things are distributed evenly around that mean. Like someone's height, for example, right? So
yeah,
let's say it's 5'8". It's probably a bit different to that, but let's say that's 5'8". People, you're going to get people who are 6'7". You're going to get people who are 4'10", but it tends to fall evenly around that mean, that kind of average height for a population. Then you've got things like, as you say, kind of less symmetric, so things like a Poisson that kind of peaks at the start and then tails off gradually. That'd be much more like someone's wealth. So there's kind of the average, or the mean value is shifted down, but the population isn't evenly distributed around it. It tails off exponentially, and then wealth's a good example to use for that. I've sent Cal some examples of these, so hopefully it'll be on screen now somewhere. testing editing skills, and I think but then there's things like tossing a coin. That's going to, in theory, that's going to be 50-50. So you've got two peaks or two uniform blocks and things like that, and that determines exactly what you do with the data. You wouldn't do a machine learning model to simulate tossing a coin. Why would you? You can do a random number generator essentially, and put some. It could be 3 lines of code. That kind of thing.
And with tossing a coin as well, John, I think it's some interesting to, and you can talk to us a bit more, is that if you toss a coin 10 times, it might be that it lands on heads 7 times and tails 3. So it's 70-30. But if you do 10,000 times, the chances that it's going to be pretty much 50-50, isn't it? So it's almost like the more you do something, and so like in a small sample, you get that potential where it can, even though it's going to be 50-50 heads and tails, you will get that that strange distribution. But when you push that up, that's when you'll see. And there's a really good I'll try and find it and link it into the video, but there's an Excel kind of spreadsheet that you can use to simulate that, where you kind of say like, do it 100,000 times, and you'll see like that it'll be like pretty much 50%, or maybe 51-49. But it's really interesting that the more data you throw at it, which is what we talked about earlier, is that the more accurate it then becomes.
Yeah, absolutely. And I think that it's interesting because the density function and the distribution around what you're trying to measure is entirely statistical, right? So you can draw up a really nice normal distribution of what you expect to happen. In reality, it might be different because the world has got multiple influences on the data that you're collecting. Not just what you expect, but there's a lot of unexpected stuff that comes out as well. So you've got things like a binomial distribution, which is a collection of, as you say, coin flips, and you can distribute that as to how often it comes up. If you have a small sample, that's more like a t-test, so that's a very limited data set. Something like a class exam is usually a good one to think about that. That normally looks like a normal, but can be wildly variable as well. And you can do some very interesting stuff with it as well. So you can work out what the probability of having a false positive on like a medical test will be using that kind of methodology. There's a lot of different impacts and implications that how an experiment or how data is collected can actually cause some differences in the expected distribution. And I think that's part of that rigor that needs to happen when it comes to doing doing any data project, is that it's essential to understand statistics, because that's almost what you expect to happen. Versus what actually happens. They're never really going to match up. I mean, in theory, if you toss a coin 100,000 times, it should be 50,000 heads, 50,000 tails. Not going to be that, unless it's
close, isn't it? But it's no, but it's not going to be exactly. Exactly.
It might be 51-49. It might be 50.01 to 49.999. There's always going to be something that causes deviation from what you expect. And that's the key to kind of making data science projects, but really any data project, is the key to making it understandable and explainable. Because if you notice a deviation that's unexplainable, I think it's best to try and explain it. Some stuff isn't explainable, and that's fine, but at least you need to know about it.
Yeah, and that's the thing, because like these things, they are predictions. For instance, if you're trying to predict sales, for instance, and your data science, you're doing it based on past data and various other variables that you throw in there. But then you could have something external that happens, like for instance, COVID. Throw that in there, and that would wildly throw what your sales might. That might, send it up or send it down. That's not something you would have built into the data science model, because it's complete unknown that gets thrown in there. So it's always interesting to know that, like, you don't want your business users or whoever it is that's using these sort of data science outputs then go, well, that doesn't match exactly to what you said it would. And it's like, well, yeah, it's a prediction. It's a prediction.
Yeah, exactly.
It could be exact, but it might not be.
And it's really interesting that now we've got essentially, in the last, we've got years worth of data that's been collected, and the richness of the data has been fantastic. But now we've got a 2-year anomaly smack dab in the middle of any forecasting you want to do. How do you deal with that? You can't build a kind of you can't build a forecast based on something that's objectively changing people's behaviors. But at the same time, COVID, as an example, has changed the world, basically. We're both working from home today, right? So that wouldn't have happened if it weren't for COVID. And that's just fundamentally changed how things do, but then people's behaviors and things like that. So how do you then adjust all the forecast, the models that you've done to account for that? There isn't really anything you can do.
No.
Other than assuming that, okay, things are just going to return to pre-COVID, pre-COVID life, and we know that's not going to be the case. But there's now a big problem, I think, in things where you do rely on historic data. Industries that rely on things like customer behavior, or how things are, supply chain, stuff like that. How do you actually account for what happened during that period?
Yeah.
You can't. You just have to
really
deal with
difficult, isn't it? Yeah, really. And it goes back to what we're saying about the data quality and data governance earlier, is that this isn't a data quality, data governance issue, but it's a complete, it's not, data science is built on looking at past trends and things like that. Whereas this is as you say, this is pretty much like a black swan. It's out of the normal, doesn't happen very often. And how do you handle that type of, how do you build data science models around that?
Yeah, exactly.
Yeah, super interesting. So you knew I was going to ask this question at some point, because it is, I mean, before I get into it, so ChatGPT, generative AI, I've never actually, so I've been involved in data now for about 15 years. And when I first started, it was quite niche. And when I say niche, it was more dashboards and reports and things like that. And people have got a little bit more wise to, I think, data science and things like that, and predictions. And we know that, you're applying for a mortgage and things like that. There's some sort of something going on in the background to tell you whether you're allowed one or not. But with ChatGPT, I've never got to a point where I've been in the pub with my friends and they have no idea what I do. None of them have ever really got any idea that I'm involved with data. They sort of know, but they have no idea. And now there's one thing that links us all. They've all played around with it. It's crazy that how much it's kind of taken off. And I get why. But what are your thoughts on ChatGPT, generative AI? I think I'm going to caveat this and say that this might not age well, because it's really difficult. It's so fast moving. It's really difficult to answer the question in terms of where you kind of see it progressing. But I'd just be interested to get your thoughts on it, because it's insane the way it's exploded.
It really is, and it is. So I've been a little bit more sort of aware of it, since maybe.
Yeah, because it's not new, is it? This isn't that new, is it? It's been around for a while, but
it's in the form it is now. It started around the early 2010s, that kind of thing.
Yeah.
obviously there's like precursors, a lot of precursors to it, as in like chatbots and stuff. I think the earliest chatbot was maybe the 50s. So it's there's been the kind of initial seeds of it for half a century now. I guess the challenge really that I see around it is that there's so much hype and there's so much like, wow, look at this thing, isn't it cool? But we've seen that before, not just in data science, but in technology, in industries, in media. You have a film that's really hyped up and it comes out and it's terrible and great. I'm not saying that's the case with large language models or generative AI, but I think it's something that I'm quite wary of. And this is I'll do the cynical part first and then the optimistic part. So the cynical part of me says that there does need to be some form of absolutely rock solid killer use case for this stuff, right? At the minute, ChatGPT is fascinating, really quite exciting. But when you come to the actual application, you can't really do anything with it because in terms of like a regular, because it hallucinates and it provides you wrong information sometimes. So how would you legally and kind of governance wise again, how would you deal with that? The answer is it'd be too complicated. So most companies would go, nope, not doing it, which is perfectly fine. Because if you got something that's providing maybe incorrect data or making stuff up, not to take that on too much of a tangent, but I watched a video by a YouTube channel called Legal Eagle, and he described that someone in the US had tried to submit, essentially build a case report using ChatGPT, and it just made up case law. Like it said, Mackenzie versus Alabama 2013 didn't exist. It's not even a real case. So it just made up these things. And until those kind of problems are sorted out, it's never really going to be. There's never really going to be like anything fundamental that will change people's lives, whether they know about it or not. Whether it's like a mortgage application or whether it's something actually where it's tangible that you're talking to. That's the cynical bit. So it needs some sort of killer use case, right? And I'd say the same about technology as well. VR, that was hyped up a lot, not to the degree of ChatGPT, but it was hyped up a lot, and it's just gone now. 3D movies gone. These things come in cycles, right? And I expect the same to happen with generative AI to a degree. The positive bit, the optimistic side, is that it's as kind of not a use case, but as someone who's interested in data science and data-driven applications. It's really interesting, and I think that someone, an individual or a company or a really focused like entrepreneurial type could come up with a really good application for these. And I've mentioned ChatGPT, but there's other like generative AI processes, like you can get deep fakes, you can get Mid-Journey, creating images, that kind of stuff. These things are at the stage where it's kind of almost fun to play with. What's the next bit going to be? And I think that I'm quite optimistic that will happen. I've no idea what it's going to look like because it's still yet to be thought of to a degree. But I think there's potentially some really interesting applications, things like healthcare. So getting people's healthcare records and actually trying to figure out early intervention. That's something that's been used for a few years now in terms of research, but LLM's got the capability of really revolutionizing that. That just ties into the ethics point though. You need to sort the ethics first before you do any of that kind of stuff. But there's a lot of really potentially interesting and exciting things that could happen with it. I just think it needs to be a bit more. There needs to be a bit more going on behind the scenes, a bit more in the research space, a bit more in the R&D kind of industry R&D space, that kind of thing. But I think once there is like a proper use case, which this is going to age terribly, I'm guessing is going to happen in the next 5 years ish, maybe. I think once that's in place, I think it has the capacity and the capabilities to potentially revolutionize a lot of things. The impact might be a bit unknown now, but it certainly will be very big and very exciting.
Yeah, it's such an interesting area, and as you say, like hype-wise, I've never known anything like it, to be honest, particularly in our industry. But you're spot on as well. Like hype, we see it all the time in this sort of industry. Like I remember, like been building data warehouses for a long time now, and I think probably, you know, about 10 years ago, I remember everyone saying the data warehouse was dead. And when I say everyone, like some people were saying the data warehouse was dead, and that seemed to have like hype behind it. And where are we now? We still build data warehouses essentially just in the cloud. You can give them a different name, but you still do it in the same way you used to do it, you know, in terms of how you model it and things like that. The hallucinations piece is that needs to be solved, because the confidence that ChatGPT or these generative AIs will tell you something, as you say, great example. I mean, I've got a you know, a more benign sort of example is when we were when we were on a particular work event and we were being asked to solve essentially a riddle. I put the riddle into ChatGPT, basically cheating, got it to give me the answer. It was super confident with the answer. Turns out it was completely wrong.
Yeah.
Not even remotely right. So it was, you know, be careful if you're going to try and cheat using ChatGPT. That's all I'll say. So I think you'll enjoy this question, John. So if you had a magic wand and you could do whatever you wanted within the sort of data science industry, what would you change and what would you like to see more or less of? It might be to do with ChatGPT, this, but let's see what you got to say.
Well, it isn't, unfortunately.
Excellent.
I think, as I say, I think that's kind of. I think that will be valuable and that'll play out, and that's just a matter of time more than anything else. So I wouldn't change anything in that space. Maybe people's understanding of it, that it's not.
Yeah, you've got to let that play out, haven't you? Yeah, it's too early to sort of change anything. Yeah. So,
I think for me, the biggest thing would be the thing I want to change would be perception. So what I mean by that is that people who aren't data scientists, who have got, you know, working with alongside data scientists, often really get quite hung up on, I want to know exactly what this model's doing. I want to know exactly what the algorithm is producing and why, and tell me what these parameters mean. And as soon as anyone starts explaining, people's eyes glaze over and they go, there's a level of the data science compared to other kind of jobs, other people's careers. It seems to be in a bit of an odd space in that I have got complete confidence in, say, a finance business partner. They know what they're talking about. I've got complete confidence in someone in HR. Like they're going to know the policies inside and out.
Yeah.
You know, I'm going to lose some stuff in some detail somewhere, and I need their support to make my job more effective, right? Same with, like, you know, analysts, people who visualize data. They're going to have expertise that I don't even come close to, and I rely on them to produce really good stuff that I can then use to you know, show off. Here's what the data is doing. Here's why it is. All that kind of stuff. Data science seems to be in a bit of a weird space at the minute, because my sense is that there's a bit of a lack of trust around data science, and maybe because that is people get a little bit burned by things going into the graveyard or whatever. But I think that if you're hiring a data scientist and there's real kind of buy-in at the senior level, there needs to be a level of trust to that individual and that team. To be like, look, you've hired us to do a job. It's a complicated job. There's a lot of, you know, maths and stats behind it and programming that maybe not everyone can understand, and that's fine. But that's why you hire different roles. You know, you don't hire, right, I've hired 20 people and they're going to do everything in the company all at once. No one does that. Maybe like a startup and with one person, but that's, you know, it's a different kettle of fish. But I think, just that level of trust. Some places have it, like I think there's been a lot of really good developments in that field. The place I work at now is fantastic in that space. Others, though, I think generally from talking to people, I get the sense that they don't feel like their team is really backed sometimes. And that, as I say, that can be a matter of previous bad experiences at a senior level. It can be lack of confidence in what's being produced because they don't understand it. They see it as a black box. So I think that I'd have people, if I could wave a magic wand and change one aspect, that probably the first one I'd change, is just making people almost a little bit more comfortable with the
Mm.
unknowns.
That's a brilliant answer. I really like the way you link that back to like, yeah, with a HR professional, finance professional, you just acknowledge that you're not knowledgeable in that area and you just hand it over. And as you say, that doesn't necessarily translate over into data science in all occasions. So I think that's a really good answer. Really good. So I want to be really conscious of your time, John. I know we've taken up a lot. It's been really, really great. But before you go, have you got any upcoming trends or technologies that really excite you within this area?
Yeah, that's a great question. So for me, I think that a lot of unfortunately, I'm really excited about what's coming up, but a lot of it's like behind the scenes stuff. So
Yeah.
a lot of the sexy, like, wow, this is cool stuff. A lot of that is I think we're at a good point where we don't necessarily need a bunch of different innovation in that area.
Mm-hmm.
For example, like visualization tools, tools to build apps, that kind of stuff. They're really good now. So there's nothing I'm like desperate to come along in terms of technology. We can do a lot of analysis using cloud-based technologies, and we can do a lot of processing in next to no time now. Again, compared to earlier when I said everything ran off my laptop locally, like it's completely night and day.
Yeah.
If I'd have finished my PhD in a week if I could have done that. That's an exaggeration. Don't hold me to that. But time waiting to compile and that kind of stuff and run would have been significantly reduced. And I think we're at a good point for that. It's like, how much more processing power do you need? We get into like things being okay in most circumstances, maybe not some of the very, very complex analyses, but for most people's use cases, it tends to be sufficient, which is good. I think for me, the main thing that I'm kind of excited about is that those use cases are going to be found that are really going to revolutionize the way in which people work, not just generative AI, but like things like applications of neural networks that haven't been done or haven't been fully proven yet. That's going to be really interesting. I think that a lot of the kind of like interesting and innovative stuff that's exciting to me is already out there and it's already being worked on. It's just how it's going to be applied that's the exciting bit. And things like the research field of data science. So I've got things like Bayesian forests being published in academia now. Those are kind of things that are going to be really fascinating to see how they can, change the way we do things. Not in a immediately like, wow, this is great way, but in like the engine room where people are creating the algorithms and stuff. There it's got a real chance to change and revolutionize the way we do things and make things much more efficient, much more much quicker, much more accurate when it comes to the outputs and that kind of thing. So for me, it's all around what's going on in the background that's the exciting bit.
Yeah.
Which is a terrible answer to give on a.
No, that's a great answer. Yeah, it's a great answer.
But
There's lots of stuff you've said there that people can look at if it's no, it's amazing. I hadn't heard about Bayesian forest as well. I might have to read up on that one. I might need you to translate some of it for me though, John, if that's okay.
That's fine. Links in the description below, everyone.
Brilliant. Thank you, John. That was absolutely amazing. I really enjoyed that, and thanks for giving up so much of your time. We'll have to definitely have to do this again sometime.
Yeah, absolutely.
Maybe when ChatGPT's really been rolled out everywhere, we'll have another chat.
Yeah, we'll see how that goes.
Thanks a lot, John.
Yeah, thanks, Kel.